Let's talk about derivative as a function. What's a derivative again? Y equals to x squared. Say if you're given a function and you want the slope of the tangent at x equals to 2, you would be computing f prime at 2. That's the slope of the tangent at 2, and it's computed as limit h goes to 0 of f of 2 plus h minus f of 2 divided by h. And you can compute this by plugging 2 plus h in here, so you have 2 plus h squared minus 2 squared, and then divide by h, limit h going to 0, and that then gives you 4 plus 4h plus h squared minus 4 over h. 4 cancels, and 4h plus h squared divided by h gives you 4 plus h, and you're taking limit of h going to 0, and you get 4. Okay. I'm doing this quickly because we've already seen this calculation. But what if there's the next question, which asks for the slope at x equals to 3, x equal to 4, and a lot of other things at the same time? Then it would be time consuming to do the limits every time you need to know the slope. So one great idea is to think about a function that will give you the value of this slope of the tangent line for any given x. So if you feed 2 into that function, you're going to get 4. If you feed 3 into that function, you're going to get the slope at 3, whatever that value is. So such a function could exist, right? And we can actually figure out exactly what that function is just by computing the limit that's given here in terms of x. Rather than using a concrete value 2 or 3 or something, we can just use x and see how far we can go with that calculation. So let's see how that works. If f of x is x squared, and you want f prime of x, that's f of x plus h minus f of x divided by h, and then x plus h plugged into x squared function means you have to square it, and you have to subtract x squared divided by h, limit h going to 0, and if you square x plus h, you get x squared and h squared, and then you get some cross terms, 2xh. Why does this one appear? Well, if you FOIL this out, you will see that this is needed. Okay, when you expand x plus h squared, not only you get x squared and h squared, which are the squares of the first two, the product of the two things doubled appears when you expand it. Okay, now you subtract x squared and divide by h, and now you see that x squared cancels. So x squared cancels. Let's see. And then limit, you get h squared plus 2xh after canceling. And h squared divided by h is just h, whereas 2xh divided by h is 2x. So when you send h to 0, you end up with 2x. So we got the function. Now, how do we use it? Well, for example, if you want f prime of 2, you would simply plug in the 2 into this function, and you do 2 times 2, and you get 4. If you wanted f prime of 3, then instead of having to calculate this for f of 3 plus h minus f of 3 over h and sending h to 0, all you have to do is plug in 3 to, just plug in 3 into this function, and 3 times 2 gives you 6, so we know that the slope is 6. So this is much more convenient. Having the derivative at hand is much more convenient. And since this is a function of x, that's why this video is titled Derivative as a Function. Now there are more reasons than what I'm just explaining for wanting to have the derivative as a function. When a function is given, the process of finding the derivative is called differentiation. So let me say that, differentiation. that means find the derivative as a function. Okay, so you have to find the derivative in general. Okay, and at this point, it seems like if you're given a function, you have to do this all the time, but there are certainly more shortcuts, and along with some more shortcuts and some memorization, you will be able to differentiate given functions very fast. In fact, that's part of the goal of this class. Okay, let me show you a couple of more examples in finding derivative as a function using the limit definition. Okay, first question. Say you're given f of x equals to 1 over x. Okay. Find f prime of x using limit definition. Okay. Solution. F prime of x. You start out by writing the formula. That way you don't get confused what's supposed to be done. So let's just write down the formula. And then, since f of x is 1 over x function and x is replaced by x plus h, you have 1 over x plus h from f of x plus h, and f of x is 1 over x divided by h, limit h goes to 0. Okay, now we somehow have to simplify this, and this certainly requires simplification because you see fractions nested inside fractions. Such fractions are called complex fractions, and the way you simplify a complex fraction is you can multiply the denominators top and bottom so you don't have any denominators. This is just one way of simplification, but for this question, this simplification is more effective than other possible ways. Okay, so why am I multiplying x? That's because if I multiply x, this 1 over x, this x and this x will cancel when I multiply them. So this won't be a fraction anymore. But what about this? This x and this x cannot cancel because of this x plus h. So although it looks horrible, we still have to multiply x plus h top and bottom also. Now you can choose to multiply whatever top and bottom. You can multiply 2, 3, or a, b, c, anything. You're free to do so. It doesn't change the value of a fraction if you multiply the same thing top and bottom. But for us, we chose to multiply x and x plus h because that's going to get rid of the denominators. Okay, so now let's see what we're going to get if I multiply that. X times x plus h, if that gets multiplied to the first one, x plus h and x plus h will cancel, but x will survive, so you're going to get x from the first one. How about this times this? If this gets multiplied to 1 over x, x and x cancels, but x plus h survives, and you get x plus h left. And it's very important that you don't forget this parenthesis. If you forget the parenthesis, you will end up with the wrong answer. And then in the denominator you have h times x plus h, and now you have to send h to 0. It looks like we can cancel this x with this x if I get rid of the parenthesis. So let's do that. X minus h divided by hx, x plus h, limit h going to 0. And then now these two x's cancel each other, leaving you with this h, but that h can be cancelled with this h. So after you only get negative h, and you see an h here, those two can cancel. And that leaves you with limit h going to 0 of negative 1 over x times x plus h. And h, when sent to 0, you get negative 1 over x squared. Okay, so what did we find? We found that the tangent line has the slope of negative 1 over x squared at a given point x. Now, let's think about an application. So, if you're given the same function, and you were asked, what is the slope of tangent line to y equals to 1 over x at 3, 1/3. If that's the question, then since x value is 3, you just have to plug in 3 to this, and the answer is simply negative 1 over 9, because 3 squared is 9. So if you have this memorized, if you memorize 1 over x differentiates to negative 1 over x squared, then when you get questions like this, you will be able to answer negative 1 over 9 very quickly. Okay, and in fact, this result should be something that you should memorize. The derivative of 1 over x differentiates to negative 1 over x squared. Okay. Now let me show you another example. The second example is when you have a square root function. Okay. What would I get if I differentiate? Solution. Write down the definition. Limit h going to 0, f of x plus h minus f of x over h. And since this time x plus h replaces the x inside the square root, you're going to get square root of x plus h minus square root of x divided by h, and sending h to 0. Now, square root of x plus h minus square root. If you see square roots and if you get a 0 over 0 type, you're supposed to multiply the conjugate. That's how you simplify it. Why is this a 0 over 0 type? If you plug in 0 for h, top and bottom, the top becomes square root of x minus square root of x, which is 0. And the bottom is also 0. So this is a 0 over 0 type indeterminate. So the only way you can figure out this type of limit is to multiply the conjugate, so-called conjugate, to the top and bottom. So you have square root of x plus h plus square root of x, and multiplied both to top and bottom. Limit h going to 0. Okay, if you have a difference and a sum multiplied together, you're going to get x plus h squared minus square root of x squared over h times square root of x plus h plus square root of x. Limit h going to 0. And if h is sent to 0, square root of x squared is x. Actually, square roots and squares cancel. So the first one, you're going to get x plus h minus square root of x squared will give you x, and then h square root of x plus h plus square root of x. Limit h going to 0. Okay, and once again we see these two x's canceling. Those cancel. You're given just the h. H is the sole survivor at the top, and that h should cancel with the bottom one. Okay, so after cancellation, what do you have at top? Because you're dividing h by h, 1 is left at the top. And in the bottom, you have x plus h plus square root of x, and you're sending limit to h going to 0, and that is 1 over square root of x plus 0 plus square root of x, which is 1 over 2 times square root of x. Okay? And this is another formula that you should memorize. You have to memorize that square root of x differentiates to 1 over 2 square root of x.